In this problem, we have to find the forces in members EF, AF, and DF of the space truss and state if the members are in tension or compression. And you see, this truss is supported by short links at point A, B, D, and E, while at the link F, three external forces are acting in this space truss. So, we can assume that our space truss is in equilibrium condition. So first of all, we have to find support reactions at links. So if we apply uh, forces in the horizontal direction, so we have a horizontal force at link D, horizontal force at link B, horizontal force at link E, and a 2 kilonewton force. And you see that the horizontal force in link B and E is negative because uh, in these links, the force is acting in the negative horizontal direction. And if we apply forces in the vertical direction, then we have a vertical force at link A and a 3 kilonewton force, while this 3 kilonewton force is negative. And if we apply the axial forces, so you see we have axial force at point D, 4 kilonewton force, and axial force at link B. So in this equation, only 4 kilonewton force is negative. And you see, we can also apply forces along the x-axis, y-axis, and z-axis. So when we apply forces along the x-axis, so you see we have a 4 kilonewton force, and it has a perpendicular distance of 1.5 meters from the x-axis. And we have also this 3 kilonewton force, and you see it has a perpendicular distance of 3 multiplied sine 60 degrees. And we have also this uh, axial force at point D, which has a perpendicular distance of 3 meters. And you see, this is negative because it is moving in clockwise direction, while all other forces are moving in the anti-clockwise direction. And uh, along the y-axis, um, we have this 2 kilonewton force, and it has also a perpendicular distance of 3 sine 60 degrees meter. And we have this 4 kilonewton force, which has a perpendicular distance of 5 meters from the y-axis. And we have the axial force at link D, which has also a perpendicular distance of 5 meters, and it is acting in clockwise direction. While we have another force, horizontal force at link E, and it has also a perpendicular distance of 3 sine 60 degrees. And you see it is also moving in clockwise direction. While along the axial direction, you see we have the horizontal force at link D, which has a perpendicular distance of these 3 meters. And we have a vertical force at link A, which has also a perpendicular distance of 5 meters. While we have also this horizontal force at link E, which has a perpendicular distance of 1.5 meters. And we have this 2 kilonewton force, which has a perpendicular distance of 1.5 meters from z-axis, and this negative 3 kilonewton force because it is moving in the clockwise direction. It has a perpendicular distance of 5 meters. So when we solve all these equations, so we get our spot reactions. So if we take the second equation, through this we can find the spot direction at point A in the vertical direction, which is 3 kilonewton force. And through equation 4, we can find the spot direction at point D in the axial direction, which is 4.5981 kilonewtons. And if we put the value of dz in equation 5, so we get the spot direction at point E in the horizontal direction, which is 0.8490 kilonewton. And you see also we can put dz value in equation 3, so we get the spot direction at point B in the axial direction, which is minus negative 0.5981 kilonewton. And you see we have dx value, so we can put it in equation 1. And you see also we have the ex value, so we get the spot direction at point B in the horizontal direction, which is 0.5755 kilonewton. Okay, so you see if we take the link D, so we can find the force in member DF. And you see this member is neither in the X, Y, or Z axis. So we are using the method of joints. So we can apply forces in the axial direction. So we have this 4.5981 kilonewton force at link D, while you see in the axial direction we have a force of F dF sine 60 degrees in the member dF, while you see this is in the negative direction because uh, this axial force is acting in the negative z direction. So as this equation is in equilibrium, so it is equal to 0. So we can find a force in member dF, which is 5.31 kilonewtons. And you see we get a negative answer, so this member is in compression. So you can also put negative sign with this with your answer. And you see if we take the link F, so we can find the force uh, in the members EF and AF. So you see here when we apply the forces in the horizontal direction, so we have the 2 kilonewton force, which is positive, and the negative force in the member EF. And you see we have member CF, which is neither in the X, Y, or Z axis. So in the horizontal direction, we get a force of FCF multiply 5 over under root 34, and it is negative. See. And if we apply force in the vertical direction, so we have a 3 kilonewton force. And in this member, so in the vertical direction, we get a force of 5.3094 multiply cos 60 degrees. Because you see, 60 degrees angle is with the y-axis, so we are using cos component. And again, we have the force in member AF with cos 60 degrees. And while with the member CF, we have 1.5 over under root 34. So if for the axial direction, you see we have a negative 4 kilonewton force. The force in member DF with with sine 60 degrees. The force in member AF with also sine 60 degrees. And for the member CF, we have 3 sine 60 degrees over under root 34. So as are these equations in equilibrium, so are these equations are is equal to 0. So if we see at equation 8, so here uh, force in member CF basically is equal to 0. So we can put the value FCF in the equation 7 or 9 to find the forces in the member EF and AF. So when we put the value of CF in equation 7, so we get force in member EF, which is 2.00 kilonewton, and we see the force in member produces tension, while in case of the force in the member EF, we obtain 0.691 kilonewton force. And you see also this force produces tension in this member.